Hi everybody. So far we've talked about the thermodynamics of making solutions. Now what we're going to do over the next few videos is we're going to talk about some of the different properties of solutions. And I've got here two beakers. Each has about 300 milliliters of water. And what I'm going to do is I'm going to go ahead and boil both of these beakers of water. But before I do that, I've got here about 50 grams of sodium chloride. And what I'm going to do is I'm going to add it to the beaker on the right. Go ahead and stir it up so we can get most of it to dissolve. And so what I now have is I have pure water on the left and I have an aqueous solution of sodium chloride on the right. So what we're going to do is we're going to bring both of these beakers to boil. So we're going to have pure water boiling and we're going to have a solution of sodium chloride boiling. And we're going to come back and take a couple of measurements and see if we notice any difference between these two beakers. Hey everybody, welcome back to our short little demonstration here. So now both of the beakers are boiling and they've both been boiling for a couple of minutes and their temperatures have somewhat equilibrated. But let's see if we notice any differences. So on the left we have the beaker that was just pure water, and of course we know that the boiling point should be right at 100 degrees Celsius. And if we look at the thermometer here, what we're seeing is about 99.6 degrees Celsius. So pretty close to 100 degrees. The beaker on the right, the one to which I added about 50 grams of table salt, sodium chloride, as you can see, it's bubbling about as rigorously as the pure water beaker, so they're both clearly in a boiling condition. But you see here that the temperature is noticeably over 100 degrees. Right now it's reading about 102 degrees Celsius. So what we have here is a phenomenon referred to as boiling point elevation. When you go from the pure liquid, in this case water, to a solution that has a solute and that same solvent, again in this case water, you see that the boiling point goes up, boiling point elevation. This is one example of a solution type of property that we're going to look at. It also turns out that you see a change in the freezing point on the bottom end of the liquid range. As you know, we throw salt on the roads in the winter to prevent the roads from freezing over. That's because by adding salt to the roads, what we do is we depress or lower the freezing point to something like maybe -2, -3, or maybe even -5 degrees Celsius. So we have here boiling point elevation. We also have the phenomenon of freezing point depression. Now the first property of solutions that we're going to get into actually has to do with the vapor pressure. Now think this through for a moment. Since this is boiling, we know that the vapor pressure above this liquid water is at 1 atm, right? Boiling is the equilibrium condition. Now if I brought the beaker on the right down to 100 degrees Celsius, the boiling point of water, we would see A, that the solution would stop boiling, and B, that would tell us that the vapor pressure sitting on top of this solution is actually less than 1 atm because it's not boiling. So there's another phenomenon referred to as vapor pressure lowering, and that's related to a phenomenon that's been articulated by a chemist named Raoult called Raoult's law, and that's what we're going to pick up in the next video. So boiling point elevation, freezing point depression, vapor pressure lowering through Raoult's law. Let's take a look at some different properties of solutions in the upcoming videos.